Okay, should we get started? I guess this is approximately everyone. We've got it despite the rain. Okay, so I thought we'd go through the exercises from the last topic, the Bertrand versus Colony topic. Okay, did anyone have a look at anything? Is there anything that people desperately want to go through? Does anyone do any exercises? Anything there? Will any of you applying for masters? You are? Economics?
Energy economics.
Energy. So any more out of a lot of you? Surprising. So why did people dropped out of this course? Because they thought it was going to be difficult? Or, but you guys were super keen mathsy people, or you were people who couldn't get into other courses? Okay, that's good. Okay. So for as an exercise, last week we went through this exercise where Q is 1 minus P, and I made a bit of a mess of it by saying you the answer. Hopefully the answer was clear. Do you want me to go over it again? You know, I just got confused myself by drawing a graph wrong. Remember that? You know, I drew a graph like this, and I thought, oh, that triangle looks the same as that triangle. Okay, it was me being a retard. I'm sure that's politically correct. Okay, so there's a lesson that it always makes sense to draw your graphs over things look a bit funny, but you don't confuse yourself like I did. Okay, so there was another exercise there which is a bit more difficult. You know, this is probably harder than anything I would ask you to do in the exam. Okay, so don't worry too much about this, but it's a good practice anyway. So doing the same thing with the quadratic demand specification. For p less than 1. Okay, so Q is this if p is less than 1 or naught. Okay, so what does that look like? So this is a quadratic, it's minimized at 1. Okay, we know what a quadratic looks like, something like this. Okay, 1 squared is 1, so this is 1 here as well. And then 0 from then on. Okay, so can we do the same thing with this demand function? Okay, so first bit, you know, is something that I could ask you to do in an exam. What's the coordinate solution for quantities here? That shouldn't be too difficult. Someone want to have a go at doing this on the board? You were quietest year I've had in a long time. Okay, so what's profits? Profits are price times quantity. Okay, so what are marginal costs? 0. We've got 0 marginal costs in the question. So profits are price times little q. Okay, what's little q? Okay, well what's the price? I guess that's what we need to know. So we need to invert this to find the price in terms of big Q. Okay, that's the first thing to do. So if Q is 1 minus P squared, okay, then square root Q is equal to 1 minus P. Okay, so P is equal to 1 minus square root Q. Okay, so this is 1 minus square root Q times little q. Okay, so normal thing, product rule on this thing. So, you know, the firm chooses little q in order to maximize their profit. So, first order condition says naught equals d pi d little q. You know, these things I'm saying, but that's ideally what you should write if you're answering this question. You know, you should always say, firm chooses whatever to maximize profits, this gives us a first order condition. You know, obviously, if you don't have time, then you don't write it, but you know, if you get to the end of the exam and you've got half an hour left to kill time, then it's always makes sense to go back and make clear your argument all the way through. Okay, so first order condition says naught is d pi dq. Well, what's this thing? Well, remember when we differentiate big Q with respect to little q, it's just 1. Okay, because big Q is the sum of all of the little q's. Apply the product rule to this thing. So derivative of this thing is just minus the derivative of this. Well, this is q, capital Q to the power of a half. Okay, rule is nx to the n minus 1, so this is going to give us minus a half q to the minus a half. Okay, the minus sign is coming from there. So this is derivative of that, and we have to multiply by that, plus this, 1 minus 3q, times the derivative of this, which is just 1. Okay, so here's our first order condition for one firm. You know, this is for one particular firm I. To get the first order condition, to find the aggregate, we always do this trick of adding up across firms. You know, strictly, okay, there should be little qi. Okay, let's be a bit more formal. Okay, so we have to add up all of the pi I profits from firm I. Let's be good. We have to add up all of the first order conditions across the firms. Okay, so when we add up, so this first order condition holds for firm 1, it holds for firm 2, holds up all firms up to firm n. Okay, so when we add them up, what are we going to get from adding up this term? Well, okay, I'm not dividing by n yet. Just adding up. Let's do things 2 steps at a time. So when we add up all the little q's, we get big Q. Okay, so this gives us minus a half q to the minus a half big Q. Okay, and then there's no I in this term. Okay, this term doesn't change across firms. When we add it up over n firms, we just get n copies of this term. Okay, so plus n 1 minus 3q. Okay, and then we can simplify this a bit. So we've got q to minus a half times q. This is just square root q. Okay, so this is minus a half times square root q plus n times 1 minus square root q. So in total we've got minus a half square root q minus n square root q. Okay, so in total we've got n plus a half times square root q is equal to n. Does that make sense? So we've got n square root q cubed minus n square root q from here, minus a half square root q from here. Take them all to the left hand side, so we've got n plus a half on the left hand side, and we're just left with the n. Okay, so square root q equals n over n plus a half, so total quantity is n over n plus a half all squared. Okay, so that's not too difficult, hopefully. So that was the first thing the question asked for, the Cournot solution for quantities. The next one was an expression from the number of firms. Okay, so to find out how many firms are going to enter, we need to know what their profits in the production period are going to be. So we need to substitute quantity into the expression for profits. Okay, well, what's little q in terms of big Q? Well, all the firms of a set. Same, sorry?
Well, it's just summation of Q. Little q is big Q, so it's over n. So.
Yeah, exactly. So they're all going to be the same, so Qi is going to be big Q divided by n. Okay, so, and the price we've got here. Okay. So let's substitute from here into here. Okay, so the profits of one firm, well, that's equal to 1 minus square root Q. Well, Q is this thing squared, square root Q is this thing. So it's 1 minus n over n plus a half times Qi, which is big Q divided by n. So 1 over n times big Q, which is n plus a half all squared. And this thing simplifies a bit. Okay, what's 1? 1 is n plus a half divided by n plus a half. Okay, so we've got n plus a half divided by, well, let me write it down. N plus a half divided by n plus a half minus n divided by n plus a half. And then we can separate this fraction. We've got n squared divided by n. That gives us an n. And then we've got n plus a half squared on the bottom. Okay, so looking at this bit, we've got n plus a half over n plus a half minus n over n plus a half. The n's cancel. Okay, so this is half over n plus a half, but we've got an n plus a half squared here, so in total we get n plus a half cubed. We've got 3 copies, and then we've got an n coming from here, so this is half. So half n over n plus a half cubed. Okay, so firms carry on entering until the marginal entrant is going to make approximately 0 profit. Okay, so as our free entry condition is for f approximately equal to pi. Okay, I say free entry, so free entry is what economists call this condition, where there's nothing stopping firms from enter. It doesn't mean that it's actually free for them to enter. They have to pay this cost f to enter. But there's no law saying that they can't enter the industry, so we call it free entry. So don't be confused by free entry and think it means there's no entry cost. Free entry just means firms can enter the industry. It's slightly confusing, but it's standard terminology in the literature. Okay, so f should be approximately equal to profits. Okay, and profits was what we just worked out, half n over n plus a half cubed. Okay, now this is when it might get a bit difficult. We have to solve this for the number of firms. Okay, so we do this. Oh, it's yours, is it?
There's someone out in the corridor as well.
Yeah. This whole building's about to collapse. Even the new buildings here are just a bit short. I say that quietly. Okay, I'm prevaricating because I'm scared of this thing. So you know, this is probably a bit difficult for an exam. But I presume if I sent you this, it's going to all simplify down to something nice. So when you cube something, you get 1, 3, 3, 1 of the coefficients on the different terms. Okay, so this is f times n cubed. I'm just multiplying out the brackets plus. Okay, so n squared times a half times 3. So So we've got 3 over 2 times n squared, plus this thing squared, so that's a quarter times 3, so 3 over 4 times n, plus a quarter. No, this isn't good. Okay, no, I think this was so in the question it was a bit of a mean question really. It's too hard for an exam. I said an expression for the number of firms. I think all I wanted was, this is correct, but don't worry about it. This is our expression for the number of firms. Okay, the solution to that equation tells us the number of firms per enter. I don't think I expected us to solve for n. Maybe it was if f was 1, we might be able to simplify things down, but otherwise just, I don't want to scare you. Okay, so, this is a nonlinear equation, it has some solution, that's the number of firms. Derive the welfare at this point and the welfare optimal number of firms. So, okay, so welfare, just make clear. You can just check that this makes intuitive sense. Okay, when you get a solution, even if you're not going to solve it, you can still see if it makes intuitive sense. So if f increases, okay, then what must happen to n? Well, if n increases, this bit increases faster than this bit, right? Because you've got a cubed here. Okay, so a small change in n is going to have a bigger impact here. So making n bigger makes this bit bigger, okay? Or look in terms of its fraction, it's making both this bit bigger and that bit bigger, but this bit's getting bigger faster. So this whole thing's going to decrease. Okay, so if f gets bigger, this whole thing has to decrease. This whole thing has to increase. If f's got bigger, the left-hand side gets bigger, the right-hand side must get bigger as well. For the right-hand side to get bigger, n must decrease. Okay, so that makes sense. Okay, f up, n down. That's what it says. So it does have some intuitive sense. You know what? I'm not going to do welfare because it's too difficult. Let's move on to something a bit nicer. Okay, so here was an exercise about Krebs-Schenkman. So this one. So show that with proportional rationing, the same price as an equilibrium in the rationing setup we looked at in the lecture. Providing Q1 is less than a quarter and Q1 bar is less than a quarter and Q2 bar is less than a quarter. Okay, so the exercise was redo what we did in the lecture, but in the lecture we did it with efficient rationing, redo it with proportional rationing instead. Okay, assuming that Q1 bar is less than a quarter and Q2 bar is less than a quarter. Okay, and we wanted to prove, the question asked us to prove that the same price was an optimum. But P star is 1 minus Q1 bar minus Q2 bar is an optimum. Okay, remember when we did it with efficient rationing, we assumed that Q1 bar was less than a third and Q2 bar was less than a third. Okay, so with proportional rationing, we need lower quantities in the first period. Okay, so it's suggesting that it's actually harder to get a Corno-like outcome from proportional rationing. Okay, and in fact, in general, you don't get a Corno-like outcome from proportional rationing. So here we're just solving the second stage. We're saying, suppose in the first stage, the firms have invested in some quantities, Q1 bar and Q2 bar, less than a quarter. Let's prove that in the second period, they would want to set this price. Okay. So what we're going to do is very much following what we did in the lecture. Okay, so we have to check if either firm wants to deviate from this price. Okay, so the first thing, we're going to do this by seeing if they want to deviate down, then seeing if they want to deviate up. Okay, so why don't they want to deviate down? This is the easy one. What happens if they reduce their price?
You make less profit.
Yeah, and why do they make less profit? So, normally when a firm is considering a price change, if it reduces its price, it increases its quantity. Okay, so there's some trade-off between price and quantity. Here, this guy doesn't face a trade-off. Doesn't benefit at all from reducing his price because quantity is going to stay the same, right? At this price, 1 minus Q1 bar minus Q2 bar. Remember, I didn't write it down on the board. The demand curve was, I think this pen is. Demand curve is Q equals 1 minus P. Okay, so at this price, we did this yesterday, substitute this price into here, but 1 minuses cancel out. What you're left with is capital Q is Q1 bar plus Q2 bar. Okay, so the total quantity being sold in this market is equal to the capacity of firm 1 plus the capacity of firm 2. So both firms are producing exactly their capacity. So if one firm reduces its price, okay, it now has more demand, but it can't sell more than its capacity, so it can't actually sell any more units. Okay, so if it reduces its price, the quantity it sells stays the same, namely at its capacity, but the price falls, so profit must have fallen. Okay, so firms don't want to deviate down. Yeah. They don't want to cut their price. So the question is, do firms want to increase their price? And for this, we're going to do exactly the same as what we did in the lecture. You just have to evaluate the derivative of profits at this optimum price. Okay, and that's going to tell us if they would benefit at the margin from increasing their price. Okay, so suppose that firm 2 deviates to selling at a higher price. Okay, well, what are firm 2's profits? Profits are profits of firm 2 are the price of firm 2 sets times the quantity that buys from firm 2. Okay, well, what's the quantity that buys from firm 2? Well, it's the residual demand curve that firm 2 faces. Okay, so with proportional rationing, the residual demand curve was given by Q of P2 times Q P1 minus Q1 bar divided by Q of P1. Okay, so with proportional rationing, this thing was the residual demand faced by the higher price firm. Okay, so firm 2 deviates upwards, it's going to be the higher price firm, it's going to face this demand curve. Okay, because Q1 bar people have already bought from the lower price firm, or are buying from the so we know that what capital Q is, okay? Capital Q of P is equal to 1 minus P. So we can just substitute that in there. Okay, so that's P2 times 1 minus P2 times 1 minus P1 minus Q1 bar divided by 1 minus P1. Okay, just substituting in the definition of capital Q. Okay, capital Q is this function, capital Q of P is 1 minus P. So we just substituted in the capital Q. Wait, you confused?
I mean, the Q, I didn't know where that comes from. QP1 minus Q.
Where this came from?
Yeah.
So this was our definition of proportional rationing. So remember, under proportional rationing, you had a probability. This thing here, this was your probability of getting rations. Okay, QP1 people want to buy from the cheaper firm, but only Q1 bar of them are going to be able to buy from a cheaper firm. Okay, because that's the capacity of firm 1, the cheaper firm. So QP1 minus Q1 bar of them are going to have to buy from a more expensive firm. They're going to be rationed. Okay, so this was your probability of getting rationed. Okay, so of the then we had that there was a probability of QP2 divided by QP1 that you're prepared to buy from a more expensive firm. Okay, remember QP1 people wanted to buy from a cheaper firm. Okay, some of those get rationed, like a random proportion of them get rationed. Of all of the people who were prepared to buy from the cheaper firm, what proportion were also prepared to buy from a more expensive firm? Well, QP2 were prepared to buy from a more expensive firm, just a random proportion. Okay, so as a proportion, it's QP2 over QP1. So this proportion were prepared to buy from from a more expensive firm. Okay, how many people were coming to buy in total? Well, QP1. Okay, all of the people who were prepared to buy from a cheaper firm. These two bits cancelled out. Okay, and that gave us the QP2 the case there. Okay, so these people are arriving at a random order to the two shops. Some of them wake up too late to get the good deal. Okay, they go to Tesco. Tesco's is sold out. They're forced to go to Waitrose. And it's random whether or not they're rationed. And the people that rationed are a random selection of the population. Okay, so they have this probability of being prepared to buy at a higher price. Okay, so this was what we talked about in the lecture. This thing here is a residual market. Okay, and then we just substitute it in. Capital Q is 1 minus P, and we get this expression. Okay, so now we have an expression in terms of P2. We can maximize this. P2 doesn't occur in this bit, right? This is only a function of P1. Okay, firm 2 is choosing P2. So firm 2 would ideally like to set a price of P2 equals a half. Okay, because you've got P2 times 1 minus P2. That's maximized at a half. So I'm writing question marks because P2 equals a half isn't going to make sense. Why is it not going to make sense? Because Q1 bar is less than a quarter and Q2 bar is less than a quarter. Okay, so if Q1 bar is less than a quarter and Q2 bar is less than a quarter, P star must be bigger than a half. Okay, if you subtract two things both less than a quarter, in total you're subtracting less than a half. If you subtract less than a half from one, you must end up with something more than a half. Okay, so P star is strictly bigger than a half. So what we've shown is the firm's profits look like something like this. Okay, we've got 0, 1, this is P2, this is profits, this is pi 2. Okay, we know that this is maximized at a half, but we started out somewhere over here, okay, bigger than a half. Here's P star. This profit function is only valid if firm 2 increases its price. Okay, if firm 2 increases its price, then it faces this residual demand curve. Okay, we've already proven that it doesn't want to decrease its price, but its profits strictly decrease if it decreases its price. Okay, so this bit of a profits line isn't really valid. You know, it doesn't have access to this bit of a profits line. So let's make that a dotted line. So the firm isn't going to want to deviate here. You know, its profit function looks like this. It's starting out at a point here. These are the possible profits it can get. Okay, you can't do any better than staying at the point where it currently is. Okay, so it's slightly confusing. I know you might think, look at this, P2 must equal to a half. Okay, but if it set a price of a half, then it would hit its capacity constraints, okay, and its profits wouldn't actually be given by this expression at all, right? Okay, so that's why it's slightly confusing. So this was, this expression for quantity, this is only valid when it's setting a price that's strictly bigger than P star, bigger than the price set by the other firm. Okay, if it sets a price lower than the price set by the other firm, everyone wants to buy from it, and its quantity is just going to be Q2 bar, which is fixed. Okay, so if you like, profits. Profits kind of look like something like that. Okay, we can check this. Suppose it sets P2 equal to P star. Okay, suppose it sets the right price. And does this give us something sensible? What quantities are going to sell? Well, hopefully this is just equal to Q2 bar. So if P2 is equal to P star, this thing here is, well, this thing is Q1 bar plus Q2 bar. This thing is, okay, 1 minus P, so P1 is also equal to P star. Q1 bar. So this is Q1 bar plus Q2 bar, then we're taking away Q1 bar. So this is, yeah, Q2 bar. And then on the bottom we've got Q1 bar plus Q2 bar. So this is Q2 bar divided by Q1. So these two things cancel out, okay, and you're just left with Q2 bar. So if both firms set exactly P2 equals P star and P1 was equal to P star, then their profits would be the right profits. That gives us the right expression. But if they set a price less than that, then this no longer gives us the right expression. Okay, because this would give us a quantity that was bigger than Q2 bar if they set a price below P star. Okay, so this is only valid if the price is strictly bigger than P star. If the price is below P star, well, their profits are just going to decrease proportionally. Okay, because their quantity is fixed, as they reduce their price, they're just decreasing their profits proportionally. So the profits of this firm look something like that. Okay, it's a straight line up to P star, and then they decline. Okay, so the best they can do is this point P star. Does that make sense? So I put question marks here because it's not going to be right. Okay, so what have we proven? Well, we started out by proving that they didn't want to deviate down. Because if they deviate down, they're getting this decreasing line. If they deviate up, then they're getting this decreasing line, but they want to deviate up either. Okay, so they're happy where they are. Okay, so this is a Nash equilibrium. So as long as Q1 bar is less than a quarter and Q2 bar is less than a quarter, we've got a nice Nash equilibrium in the second stage, where they set this price. I think what you'd find if you did the first stage of this game is that you wouldn't be able to prove that Q1 bar was less than a quarter and Q2 bar was less than a quarter. Okay, so with proportional rationing, remember with proportional rationing we said that you tend to get prices that are lower than the Corno price. Okay, that means quantity is higher. Okay, so let's do some of the exercises from the book now. Yeah?
Sorry to take us back one step.
Don't worry.
But how exactly do we know that P star is greater than half at Y?
Because we just assumed that Q1 bar was less than a quarter and Q2 bar was less than a quarter. Okay, so that was an assumption that was given to us in the question. Okay, the question said assume this, and P star was defined as 1 minus Q1 bar minus Q2 bar. Okay, so well, let's prove this formally. Well, Q1 bar is less than a quarter and Q2 bar is less than a quarter. Then Q1 bar plus Q2 bar is less than a quarter plus a quarter, okay, which is equal to a half. That makes sense? Okay. So let's subtract this from both sides. Okay, so 0 is less than half minus Q1 bar minus Q2 bar. Okay, now let's add a half to both sides. So half is less than 1 minus Q1 bar minus Q2 bar. Well, this is just the definition of P star. Okay, so this is equal to P star. So what have we proven? That half is less than P star. So it's really just, we're assuming this, and this is essentially giving us exactly what we need on P star. Okay, for P star is to be bigger than a half. So when we did it in the efficient rationing case, just a second, when we did it in the efficient rationing case, we were able to prove these restrictions coming from the behavior of the first period. They gave us these restrictions. Okay, here we're just assuming them to make it easy.
Can you repeat what happened in the last two equations again?
Last two equations, okay. So you happy with this one? Yeah. Okay, so we subtracted this from both sides of the equation. Okay, so we subtracted Q1 bar plus Q2 bar. So Q1 bar plus Q2 bar minus Q1 bar minus Q2 bar, that's equal to 0. Okay, on the right hand side here we had a half. When we subtract Q1 bar and Q2 bar, we get a half minus Q1 bar minus Q2 bar. That makes sense? Okay, and now we just add a half to both sides of the equation. So 0 plus a half is a half, half plus a half is 1. So this is 1 minus Q1 bar minus Q2 bar. Well, this thing was our definition of P star. Okay, so this is P star. So that says that half is less than P star. So the rules of manipulating inequalities are very similar to the rules of manipulating equations. Okay, the only thing you've got to be careful about is you can't multiply both sides by a negative number. If you multiply both sides by a negative number, then you need to flip the sign. Okay, so if A is less than B, then minus A is greater than minus B. Okay, that's the rule. And likewise, the other time you have to flip is when you invert both sides. So if A is less than B, then 1 over A is bigger than 1 over B. You want?
But then in the first time we did it, if the price was less than the price if it was less than P star, and then after it said if it was greater than P star.
Yeah.
But then when we maximised the profit, we had a price that was less than P star. That doesn't make any sense.
Well, that's why I wrote those question marks after the half, right? So that wasn't the... We had the profit function looked like this. It was price times P2 times Pi2, 1 minus P2 times some constant. Okay, and I just said, well, if this was really the profit function, then yeah, the maximising price would be a half. Okay, but this was only the profit function if the price was bigger than P star. Okay, this profit function was only valid when the price was bigger than P star, because we were using that formula for the residual demand curve, which was only valid for prices bigger than the other firm's price. Okay, residual demand curve is the demand curve that a firm faces if it's the higher price firm. Okay, so the residual demand curve is only valid for prices bigger than the price set by the first firm.
So that profit function we used isn't valid because the price was less than...
Well, the profit function is valid as long as, okay, so what we had was if P2 is greater than P star, then Pi2 equals P2 times 1.
Right, so the profit, it wasn't valid then?
Well,
so it's valid for anything right at that point.
Yeah, it's valid for anything right at P star. So it wouldn't be valid at a half. Okay, so what? Let me draw this picture right now. Okay, and this was. Okay, so this is just for reference. Okay, here's P star. This is 1. This is 0. This is a half. So there are two ways you can go about this. Okay? So one is to do what we did in the lecture. You differentiate this function with respect to P2, and you substitute in P2 equals P star. Okay, so let's do that. So d pi 2 d P2. Well, what's that? So this is P2 minus P2 squared. Okay, so this is capital K. This is just the constant, whatever it was. Capital K times P2 times, 1 minus 2P2. Okay, and then I substitute in P2 equals P star. Okay, so at this point, this derivative is K1. 1 minus 2 plus 2Q1 bar plus 2Q2 bar. Okay. Q1 bar and Q2 bar are less than a quarter. Okay, so the sum of these things is less than a half. 2 times the sum of these things is less than 1. Okay, so this bit is less than 1. This is 1 minus 2 is minus 1. So we've got minus 1 plus something less than 1. So all of this thing is negative. Okay, so what this tells us is that at this point, profits are decreasing. Okay, so an increase in price, which is the deviation we were considering, an increase in price would lead to a fall in profits. Okay, so they don't want to deviate upwards. Okay, so that's one way you can approach the problem. That's what we did in the lecture. The other way you can approach the problem is you can think, well, the profit function the general profit function has to look something like this, okay? And what we need to know is whether we're to the right or to the left of the maximum. Okay? If we're to the right of the maximum, then we do want to increase our price. If we're to the left of the maximum, then we do want to increase our price. If we're to the right of the maximum, we don't want to increase our price. Okay, because the profit function is different below that point. Okay. So this function here is maximised at a half, P star is bigger than a half, therefore we started out to the right of the maximum. We've already shown that we don't want to decrease our price. If we're to the right of the maximum, then we don't want to increase our price either. Okay, all we were trying to establish in the second half of this proof was, do we want to increase our price? So we only need to consider moving upwards in price. Okay, so the observation that this was maximised at a half, this is just a kind of a quick way of doing the same thing involving differentiation. Is that clearer?
Yeah.
Moderately.
I mean, like the second way you did it, when you did the
differentiation, you like that?
It decreases. I think that shows that they wouldn't make it higher.
Yeah. Okay.
Rather than the way you did it before, where you maximised it if the increase in the price was lower. That was confusing me, but I get this.
Okay. Well, as long as you get one of the two approaches. Okay. So. Yeah, I wasn't, with a maximisation approach, we weren't really maximising. We were saying, well, we've got this function, okay, which is only valid for P2 bigger than P star. Let's just forget for the moment that it's only valid for P2 bigger than P star. Find out where the maximum is. Okay, if the maximum is to the right of where we are, okay, then we want to increase profits, right? If by going right, by increasing price, we can increase profits, we can get closer to the maximum, and that's a good thing. Whereas if the maximum is to the left of where we are, then we can't possibly get closer to the maximum by increasing our price. Okay, so this thing is maximised at a half. Okay, we're a point over here, therefore we don't want to increase price. That was for you. Whatever works for you, really. If this is clear, stick with that. Are we happy, everyone? Do so.